Hi, everyone. This is Jules Urbach, the CEO and founder of Otoy. And this talk is about the future of GPU rendering at GTC 2020, Fall Edition. This year marks the 10th year that I've been doing GTC. In fact, my first talk was in 2010, and we've sure come a long way since those years. I was actually on stage with Jensen in 2013 talking about cloud rendering on GPUs, and every year I've sort of talked about where things are heading in the next decade or so, and here we are in 2020, and things are very exciting. We just had the launch of Ampere. The future of GPU rendering is bright indeed, and I'm excited to share this with you. So Otoy's mission is to democratize content creation, and we see the future of content creation is moving towards volumetric and even holographic content, and so we're focused on various parts of that pipeline, from capture to rendering to streaming on the cloud. But we're probably best known for OctaneRender. And we launched OctaneRender about 10 years ago, and it's really improved a lot over the many years that it's been out. Octane 1.0 was focused on still images, and it was a real game changer for GPU rendering. At the time, people really weren't sure whether GPU rendering was going to turn into something viable versus CPU rendering. And I think now it's pretty much settled that GPU rendering is a huge place to play in the industry, and that's been very gratifying. We launched Octane 2.0 with animation support, motion blur support, and around Octane 3, mid-decade, we started to see Octane being used for visual effects and cinematics, which is awesome. And we want to show some of the recent cinematics that are done in Octane. This is from films and television shows that are done using OctaneRender. Enjoy. That was just a sample of the amazing work being done in Octane every day, every year. We've also had a couple of Marvel films that featured Octane. This is from the opening of Ant-Man and the Wasp. The entire title sequence was all rendered in 4K stereo for that film. And more recently, the Captain Marvel title sequence. So it's exciting to see GPU rendering being used for these high-end productions. And as I was saying before, I mean, this is really the year where GPU rendering, I think, has come into the forefront. We have Arnold on GPU. RenderMan XP is looking very promising. It should be out by the end of the year. So it just feels like the place for GPU rendering in production is kind of settled. As far as what we've been doing to democratize this rendering power is building Octane plugins for almost every single DCC tool. So there's about 26 integrations. All of those are available for one low subscription price under $20 a month. And as we sort of look forward with GPU rendering beyond just what it could be used for production, obviously GPUs were initially created for video games. And so the future of Octane and many of the things we're working on really does seem to trend towards real time. And to that end, around 2018, we started working on making Octane work inside of real-time game engines. We launched Octane for Unity. It's a integration that's done in partnership with Unity, and it's been around now for a few years. And it allows you to take any of your Unity assets and scenes and render them at Octane quality. So that brings Octane for free to millions of content creators, developers, and that's been a very exciting partnership that we look forward to continuing for years to come with Unity. As we look forward, of course, to making Octane faster, and as we have newer hardware like Ampere and RTX, even games that are rendered with full path tracing quality in Octane become viable. We've also created a pipeline where you can take assets from any other GTC tool and bring those right into Unity as well. And that's extremely helpful because not everything can be created in Unity. There's a lot of things that are lost in interchange assets today. So having all the lights and materials from the various Octane GTC tools brought in through Orbex, very useful. We, 2 years ago, also launched Octane for Unreal. And Octane for Unreal and Unity are both free on one GPU. And it has a very similar set of features. And it's been very popular. We have seen a lot of really high-end real-time work being done in Unreal, and we complement that with having a production path tracer inside of Unreal. But as we also work towards adding technologies that bring path tracing, even at cinematic quality, to real-time, we see Unreal as being a proper GTC toolchain and workflow for our users. And also a lot of virtual productions are leveraging Unreal, so we get a lot of requests for that as well. Pretty much everything that you can do in Unreal, the entire HLSL shading pipeline gets converted to Octane, so it just works out of the box, which is really cool. It's one of the unique features of that integration. We've also added support for VDBs and other things that are, in some cases, difficult to render with rasterization. So beyond real-time game engines, we're looking at many different factors that GPUs are opening the world to. And that includes, obviously, AI, and as I was mentioning before, even holographic content is something that we're seeing coming into the forefront. I'll talk about that in a little bit. I want to start by going through what Octane does feature-wise, because not everyone necessarily is familiar with Octane and what it does on the GPU. So I think it's worth doing a quick recap, starting with last year. And the things that we added, we included a pretty great AI denoiser in Octane. It's custom grown and it works on cuDNN and out-of-core geometry and very fast procedural lights. And even vector primitives, which are a lot like ShaderToy. You can create your own OSL shaders to generate any object you want. This is Octane's denoiser in action. It's pretty amazing. I mean, it takes render times down to almost nothing, and it works through glass and refraction. So again, very powerful stuff. This is the fast volumetric work that we were doing last year, and that's now in Octane. So single scattering, volumes really fast. And on top of that, we have AI denoising on the, specifically for volumetric passes. And last year, we significantly improved the quality of the volumetric denoiser. So mixing these together, you have really fast volumetrics that look really good. And we're not done, and there's always room for improvement. So we're always continuously working on making volume rendering faster. We also added OSL and vector displacement. That's something that a lot of users wanted. We've always had texture displacement in Octane, but this allows you to have both vertex and texture displacement. We also introduced OSL volume shaders, so you can pipe any sort of procedural effect into volumes as you please. And there's been a lot of discussions around whether OSL materials makes a lot of sense. We did put that into Octane a couple of years back. And we opted instead, though, last year to switch paths and focus on just doing layered materials. That's also in RenderMan. We feel like is essentially what you can do with OSL shaders for materials, but in a node-based system. And it's very artist-friendly, and it works great. We also added a universal camera system, which allows you to create shaders for cameras and also do distortion maps. And this year has been great. I mean, we've had 2 releases of Octane, and I want to talk about those as well. So Octane 2020 went into beta in November of last year and actually was released in April as a stable release. But one of the biggest features that was added to Octane 2020 was Optics 7, which allowed us to leverage ray tracing hardware. And that's something that we've been tracking for years. And we've been very excited to see that now become mass market. So in a lot of scenes, you have 2 to 3 times faster speed when the tracing is handled by the hardware versus CUDA. And that's a pretty sizable speed up. It's not in every scene, but overall, we're seeing at least 30% speed ups, and in a lot of cases, it is 2 to 3 times faster. And it's trending towards more modern scenes having greater speed ups, which is obviously very good. There are cases where it's even faster. This is a scene from NES Graphics, 15 times faster. That's an outlier, though. I mean, typically the speeds that we're seeing in that range are from tons and tons of overlapping triangles and instances, which ray tracing hardware is really good at doing. why we chose Optic 7 over other APIs for Octane sort of comes from our experience working with Vulkan and looking at DXR. We did try building a version of Octane on Vulkan last year, and it had issues, mainly with CUDA Octane interop. So Optic 7, which was a massive improvement over Optic 6, really did everything that we needed, and we've settled on that going forward for Octane, and it's been working great. We've also made some improvements just recently, moving a lot more of our shaders from CUDA over to things that could be running on RT cores, and that's resulted in a 1.6x speed up in a lot of scenes that just weren't seeing any speed up at all with RTX. So that's been pretty great. And as far as where we're going from here, we want to do further optimizations for splines, curves, rounded edges. All of that is in progress. And on Ampere, we're also currently working on motion blur hardware ray tracing support, which is going to speed that up significantly. So Ampere's been really promising, and we're going to get into that as well. In general, with RTX, we're adding support for out of core and lower memory footprint. And at that point, we just feel that RTX on is always going to be the default on Turing and later. And that's already the case in Octane 2022.2. The Ampere cards that were just released are frankly just awesome. We're seeing 2x speedups over Turing pretty much across the board, from 3080 versus a 2080, 3090 versus a 2080 Ti. And that's insane. I mean, we don't really typically see that kind of speed up generation to generation. And it's reflected also in the scaling of Octane Bench, which is our benchmark. To see 1400 Octane Bench, which used to take 8 GPUs, having that run with 2 is just absolutely crazy. And there's much more to the Ampere speed up than just Octane Bench alone reveals. What we're seeing is that the RTX cores themselves are faster, or there's more of them on Ampere. So the RTX on versus off speed up is about 1.5 times faster on Ampere cards. And that's really going to push the speed up much higher than what Octane Bench is showing. Octane Bench is very conservative. It has scenes from 5 or 6 years ago that don't really have as many triangle intersections. When we load in newer scenes, the scores are really different. And what we're seeing after testing about 40 different scenes, all of which we're looking at actually including in a future Octane Bench, what we're seeing is the Octane Bench score is more like 50% or 30% higher. And that would mean that the Octane Bench score of a 3090, 3080 would be, instead of 600 or 700, probably closer to 900 or 1000. And that will probably be reflected when we update Octane Bench 2021 next year, with all the RTX optimizations and also many more scenes that push things further. And that's a natural progression. So that's pretty exciting. And as far as features go, there's a lot that we've added in the last 6 months. So I'm going to go through those, at least highlight the ones that we think are salient. We added, with Maxon's help, native Maxon GPU noises, which are awesome. No texture baking needed for these effects. It works just great with volumes and displacements. To that effect, we've also added procedural support for Vectron volumes, which are really cool. You can also have operators between them, so you can create totally procedural volume effects like you're seeing here, and these are all done live at render time, so there's no baking. And it's really, Vectron's, for something this simple, it truly feels like it's a forward-thinking part of our rendering pipeline. And we've also been working on things like subsurface scattering. So random walk was added in 2020.1, and it looks great here. You can see it in Blender. It's super fast. And random walk's fantastic effect for skin and other surfaces that are typically difficult to render with many layers. Here are other examples of random walk applied to things like wax. Now, along those same lines, we introduced a spectral hair material in Octane 2020.1, and it looks beautiful. That's huge help. It's based on the Disney hair BRDF, which a lot of production renderers are adopting, and we've adapted it to Octane. Octane's a spectral renderer, so all of our materials and the like are also spectral as well. And we also introduced volume displacement support, which makes instanced displacement on volume something that is really powerful. And we introduced a new dirt shader as well, which gives you much more control and flexibility. You can use it as an ambient occlusion pass. We also, in addition to working on speeding up the tracing pipeline, have sped up the shading pipeline as well. So Octane has been typically using mesh lights. Now you have in Octane 2020 light primitives for quads and points, and that's 4 times faster. So huge help. With those light primitives, you also have spread functions. You can define those in OSL, but we shipped some of those with Octane. We also added native curve and point primitive attributes. And for the universal camera, we added some cool new features like split focus diopter, optical vignetting, aperture textures, and many more. Open Color I/O is also in Octane this year, and we're continuously working on it and improving it, but it shipped in 2020.1. There's more that's in the current 2020.2 release, and we expect to have full support by the end of this year. And we also shipped a Hydra render delegate, which works in any Hydra render application. In this case, you're looking at it in Houdini's Solaris. And 2022, which just came out a couple months ago and is close to release candidate, introduced things like nested dielectrics, which look awesome. Also, many utility shaders that have previously been in OSL are now shipping in Octane. So distortion textures, chaos texture mapping, which allows you to have unlimited tiling, improved gradient tools, and many of the most popular community OSL shaders, such as RGB splitter utility nodes like RaySwitch. All these mathologic and state nodes are going to be in 2020.2 and part of the core. We've also added a compositor node system. And some of that is used for doing things like multi-light, which you're seeing here. We can use it both for textures, such as a graph that's being done entirely in texture nodes. But Octane 2020.2 also adds support for this in the imager stack. And what you're seeing here is multi-light implemented entirely in the post stack. Really simple, really easy to use. Also, pretty powerful. You can take any of these different AOVs and combine them how you wish, and even do really interesting custom AOV effects. So every compositor node graph creates a custom AOV. I can pipe the info channels into a different color and mix those with the beauty passes. So a lot of powerful things there. All can be done now within the Octane core system. And debug AOVs, again, are pretty straightforward and easy to do. You can take the wireframe shader and mix that and do compositing operations. Even take bitmaps now and add those into the AOV system. One of the things that people have really been looking for, though, is a way to do very fast and quick fog, even as a post effect. And now that's possible as well with the very same system. So you can do Z-depth and even position map blending and generate fog essentially for free, all in post. And it's really easy to use, really easy to adapt, and actually looks really good, surprisingly so. There's more that we could be doing with this, but this is really sort of the first step towards more advanced post effects. And it's something that, again, works even with the denoiser and many other parts of our rendering system. We've also improved the scattering system. We want to take what's been traditionally something that's only been in our C4D plugin called Octane Scatter, which is a very advanced scattering system, bring that into core, and that is now in Octane 2020.2. The baseline for doing more work with scattering, where we can move this to the GPU and eventually do animations. But we've also added support for doing really complex procedural scatters. So that's something that hasn't been possible or easily possible before in the core of Octane, and now it's in there. We also, in April, released another major software service called Render. It had been in beta for many years. Render is a decentralized GPU blockchain rendering service. And we've been doing cloud rendering for Octane for many years. We did a partnership with Amazon going back almost 7 years. And what we found is that there just aren't enough GPUs on the public cloud. And we're partnered with many of these providers, but big clients just run out of GPUs. So really our goal was to decentralize GPU rendering, provide all the nodes that are out there, all the GPUs in the world potentially to power render. And we've launched a cryptocurrency token that is used to pay out these render jobs, essentially at the same price point that you would pay Amazon to do the same work. So the token is actually based on the Octane bench cost of Amazon. And of course, it's a free market, so the price can go up or down. But ultimately, we want to provide many more GPUs out there and let the free market decide the costs that users will bear for that. So the way that Render works is you have a system tray applet that runs on any machine, and instead of mining Ethereum tokens, you can just fulfill render jobs, and it's pretty great. Since we've launched in April, we've had 6,000 artists subscribe to Render, and some of these artists have been spending hundreds of dollars in renders, and others just a few dollars. But it's still very early. I mean, we see this growing significantly, and what's really been awesome is that we don't need to have our existing cloud rendering service anymore. We've built an enterprise tier for Render that allows you to do secure rendering, and we also provided render credits for artists that allow you to skip the whole cryptocurrency thing if you just want to pay in fiat. And this is how Render works. It's a web-based interface. You can export your scenes to Orbex, which all Octane plugins support. You can drop that into the web page, and it'll just do the render for you. You have different settings for priority. You can choose to pay in cryptocurrency tokens, render tokens, or in euros, which are backed by render credits. And credits themselves really came about from the need to, during beta, to come up with something simpler than crypto wallets. And we think that in the future, that's not going to be much of an issue. But today, a lot of artists just aren't that familiar with cryptocurrency. And so having the ability to use Render by paying us in PayPal or Stripe is kind of an important on-ramp. So Render credits, which you can buy today on the site on render.otoy.com, are essentially mapped to 4 tokens. And that also allows you to spend those tokens on any of the tiers, both public and enterprise. So going into what these 2 tiers do, public tiers are the ones running on untrusted nodes. It could be anyone's machine. It is incredibly secure. There's end-to-end encryption, but the enterprise tiers are TPN studio certified, so you could do your Marvel movies on those. And those enterprise tiers truly replace our prior service, which was running entirely on AWS. And the public tiers also have other things to help with the fact that they're untrusted and decentralized, including watermark and escrow, and you also have different priority settings, so you can really get very cheap rendering on the public tiers by a factor of 8 or more versus traditional render farms or certainly the public cloud. So the enterprise tiers have super high-end systems, though. For example, we partner with Google, and they provide 16 A100s, which are absolutely insane. Some scenes need that. Some partners want that. So you have really all options available on Render. The first commercial job that we ever did, and it was actually right before we launched publicly, was with John Knoll, legend in the industry. And he was doing a project for the Hayden Planetarium. He needed it done in literally a day. It was Octane for Moto, and Render delivered, and it was absolutely awesome. So having that be our first commercial customer was very auspicious. And since then, we've had tons of artists do amazing work. We also have directors using Render. I can't reveal some of those just yet, but I can't wait to share. Here's a beautiful sample. That looks awesome, right? I mean, the great thing that I've seen Render actually used is getting feedback on how simple it is and how it works for our partners and our friends. This is deadmau5's latest video, and done in Octane on Render. So yeah, you're seeing real commercial work being done on the blockchain on random people's machines. I mean, they're not totally random. There's a process by which you could sign up for it, and currently we're, we are sort of whitelisting people, but as we grow the user base, the scale of this thing is unlimited, and it works great. I mean, I think it's one of our most popular products. And the Octane user base as well. I mean, if we just added those GPUs, it's a huge amount. We have about 50,000 just Octane 2080 Ti's, or sorry, RTX 2080 Ti's in the Octane subscription pool. So there's just a ton of rendering power that we could be throwing at the service. Now, we have major partnerships that are also announced this year and that are in progress. First of those was with Autodesk, and Arnold is coming to Render. So Render is not just about Octane. We want to support every major GPU render on the service that we can, and we've been talking to Arnold for years, and the team at Autodesk has been fantastic. And this partnership is more than just bringing Arnold to the render service. It's also about coming up with standards that both renderers can use so that materials and object interchange can be simplified. And there's still a lot of missing pieces, even with things like Material X, that we want to solve by partnering with the Autodesk and Arnold teams to figure out how the same scene can essentially render in both Arnold and Octane. And a lot of that work is happening by Octane adopting Arnold Standard Surface, which we think is a great format. Now, on the enterprise side, we have many partners. We announced right after Render launched that Microsoft is joining Render. They've been fantastic. We're working with them on, of course, adding Azure as Render Enterprise tier nodes, but they're also working with us on securing the decentralized systems that we have on Windows 10, and also helping us with driver support and also storage, which is essentially a problem that can take a lot of time. I mean, sending data back and forth between render nodes on the system is something that can be improved, and Microsoft's help is very welcome in that regard. Google also has joined the Render network, and they have brought something truly unique to the table here with these Ampere A100 instances. Those are truly the fastest GPUs that you can get on the cloud, and it's amazing seeing the Octane bench results here. 8,000 Octane bench with the 16 A100 node is just incredible. It's really almost double what was possible before this generation existed. And you can also get 12 or 8 or 4x of these and choose the amount you want on Render. When Google was actually testing it out, they sort of broke Octane bench by having such incredibly high scores. We had to change the rendering of the benchmark to be logarithmic so that you can see these scores more clearly. Now, Render Phase 4, which is following all the work we've done around getting essentially the high latency jobs working, is really exciting. We're in that phase right now, and a lot of that work is focused on leveraging the blockchain portion of Render to allow people to transfer things based on the render token value relating to IP, their art, all of that. And we also want to introduce other services. Obviously, AI is another low-hanging fruit. We talked to John Carmack about some of the things he's trying to do on the cloud with AI. And we're also going to go and look at low latency GPU render jobs on Render. It could be cloud gaming. We used to do app streaming. All those things are viable even on a decentralized system. And we have an SDK that allows you to build apps that can be leveraged on the Render network. And we've built Octane on top of it. We're adding other tools and software partners pieces on there. And we want to see that happen. So the other major announcement that we have around Render, and something I've hinted at before, is that we want to use the Render token to essentially provide an alternative to our subscriptions. So our subscriptions are paid in euros right now. But in the future, once we have liquidity and Render tokens being considered by Coinbase, and we expect it to be on major exchanges probably by the end of this year, we want to be able to provide an alternative where you can use the tokens to actually pay for our subs and our services. And this is something we're going to be starting in the next 18 months. And it may be that providing Octane for free, for example, but having it so that you pay for the GPU power you use, even if it's fractional, could be an interesting model and something I wanted to try for a decade. And here we are now with Render and everything else kind of getting to the point where usage-based licensing seems viable. And we've also offered the same to our partners. So we've added other pieces of software like EmbergenFX, which I'll be talking about in a little bit, as part of our subscription offering. And the idea of providing tokens that can cover that through usage-based licensing is something that partners like DjangoFX that builds Embergen are interested in following. So there's a lot more on that in the coming months, but it's a very exciting prospect for our users and I think the industry in general. NFT, non-fungible tokens, is something that is super interesting in the crypto space. You're seeing a lot of artists, and Octane users in fact, look at having crypto art, which is where you have a unique piece of art and there's a crypto token, non-fungible, that backs that. And it just feels like that is something that is truly a sort of an easy convergence with Render. And we've always imagined that the art that you create with Render, powered by Render, could also have other secondary effects. So we've offered that as something that artists can leverage and use. And especially when it comes to objects in AR, where you want to have rules and all sorts of smart contracts that can be used to determine how these properties might work. A lot of potential there, a lot of interesting, viable areas we could be exploring for these things. And in fact, the artists I mentioned there, Alex Ross and Beeple, we've done tests with them around taking their Orbex exports from Octane and dropping them in AR and having things that could control how they get viewed, and even with partners like BAT, Basic Attention Token, we could do things like ad-based support for these things. So there's a lot of potential there. And from the services and software perspective, the Render SDK is pretty fundamental. It's a portable graphics API and compute framework. We've used it to build all of Octane, and it does have multiple backends, which is great. You can use it to publish your own render modules, and that's how, behind the scenes, we're bringing other software besides our own to the service. But we eventually intend to build the Render SDK right into Octane itself and the tools that we put out there, so you can basically create your own types of jobs and services, not just things that we imagine or cordon off in a specific realm. The front-end language for render is GLSL. That's actually what Octane is now written in, and it has different backends that can author, run on many different devices. So we're also creating other renderers besides Octane in it, like Brigade. And there's a lot of other high-level functions in the Render SDK, such as support for simulation, physics tools, scene graph tools, and even hybrid render delegates, which we'll show in a little bit as well. But the back-end work means that you can take your render applications, whether they're running on the decentralized network or locally, and they'll run on D3D, Metal, CUDA, anything. And that means that pretty much the software works almost anywhere. So back to Octane and where we're heading. As I said, this year and even the last 6 months since the last GTC talk, lots happened. We've shipped a lot of features. The next set of features that we're working on are really driven by users. User feedback is fundamentally important. We're about 50% of the way through the next release. It should be out in winter. And stability and performance are really the two biggest goals. We think we're in a pretty good place feature-wise with Octane. Obviously, there's always more to do, but a lot of the stability and performance work done in 2020.2 will just continue to be focused on as we work on this next release. So one of the things that we're working on is multi-process, where we can run Octane in its own process, and it doesn't affect the host app if it goes down. We're also doing automated GPU error reporting, and we built an AVX version of our GPU denoiser. It's currently shipping on the Mac version of Octane, and we're going to bring that to Windows and Linux as well. So that'll mean that you don't need to use the GPU for denoising. Sometimes that pushes the GPU to its limits, so having an alternative is good for stability. On memory, tons of work being done there for optimization around out of core. There's many improvements that we could do since we introduced this feature in Octane 4, and we think that'll be a major boost to allow you to have a lot more primitives in memory. And in addition to the work that we're doing with that and NVLink, you should be able to load on a 3090 many billions of primitives in VRAM, unique primitives, which is pretty cool. And that's going to help a lot with high-end production scenes. We're also working on improving memory with things like having grayscale images converted when they're only a single channel automatically. In volumes, we're going to add things that users have asked for, like having the focus picker ignore volumes. And there's a lot of other features that we're working on along those lines. We're also going to fix the visible lights and volumes. For render, some of the goals that we're adding to core that we have are delta syncing. This used to be in org. We've built this before. We're bringing that into render as well. It's a little bit more complicated on the decentralized network, but that work is about halfway done. And the other major work underway is to improve the exporting of Orbex packages for render. So if you're coming from C4D or Blender or Houdini, we're going to be supporting many more procedurals, so there'll be less baking, and the exports will be faster, smaller, and easier to upload. Now, render also includes other modules besides Octane, as I mentioned before. Brigade is one, Sculptron's another, and we've also started to add third-party modules. And we did that this year in partnership with EmbergenFX. We launched an awesome tool called Embergen. EmbergenFX is a GPU volume simulation tool, and it's incredible. I mean, as you're seeing here, you can essentially run these simulations live on a single GPU. EmbergenFX as a standalone tool is actually currently free while it's in beta for all Octane subscribers. That's an incredible deal. And over the course of the next 6 months to a year, we're going to be developing a tight integration of Embergen inside of Octane itself. So you won't have to export your Embergen assets as VDBs. They'll just be simulated and render right within Octane and even Brigade. And it'll work in all DCC tools. So that's a huge boost, and it's something that we're super excited to be doing in partnership with EmbergenFX. Embergen is just amazing. I mean, it does have a lot of capabilities, even just interactively while you're moving objects around. So a lot of what's missing in the standalone tool you're seeing here is the ability, for example, to take your C4D scenes and your normal workflows and just mix that with Embergen Live. Now, being able to bring EmbergenFX directly into the DCC tool of choice through this integration is going to make a lot of artists have a much simpler workflow. The other recent feature that's just launched this July in Embergen is particles. So GPU particles in Embergen are absolutely awesome. We're going to be supporting those as well with direct native rendering inside of Octane and Brigade. And between Embergen and our other tools, we're actually having a pretty robust suite of software that is complementary to Octane itself. And we're looking to add more. So, you know, Embergen is really the first third-party tool that we've brought into the mix. Sculptron, which we'll be showing later, is a GPU sculpting tool. All of these, of course, are GPU-based, but you know, we have one announcement today that's pretty exciting from a new partner, and that is World Creator. Now, World Creator and us are going to be doing something very similar to what we just showed with Embergen. We're going to be bringing World Creator and Octane together, and those who don't know what World Creator does, it's an absolutely amazing procedural GPU tool. It allows you to create these beautiful landscapes. These are actually rendered in Octane and created in World Creator by amazing artist Aaron Westwood. And World Creator and Octane go perfectly together. They're absolutely fantastic tools. And take a look at this video. That was by Aaron Westwood. That was a short film done in Octane and World Creator. It just shows the power of the system. I mean, we feel having more tools that are GPU-based, that are procedural, that artists can leverage, just helps the workflows that we've already been leveraging just with Octane. And you know, having a much tighter coupling between these products is fantastic as well. I mean, just having the ability to take World Creator nodes and having those embedded inside of Octane DCC tools so you don't have to have a separate app. It just brings together the same benefits, cross-DCC pollination that we've targeted with Embergen. So again, having all of these in one subscription package, which we'll be doing as a bundle towards the end of this year, super exciting. Back to feature development for Octane itself, you know, beyond sort of the big things that we're doing in core, there's a lot of features that have made the to-do list, such as geo-clipping, which you're seeing here. That should be out in a release this year. It's already halfway done and it looks awesome. The other major improvement is around shading. You know, as much as RTX has helped with tracing, shading is still about half of the rendering work. So being able to have faster light sampling, you know, with 2x faster speeds, as you're seeing here, is going to make a big difference. And that also is about 50% of the way done. So that should be out this year. We're also adding for curvature nodes, MIP maps, parallax occlusion maps. Rounded edges as a texture node will be supported. Random color textures, unique objects for layers and instances will also be in place probably by the end of this year. And as far as the BRDF improvements go, we're working on a number of things. They're also about halfway done. Multi-scatter GGX is nearly complete. And we're also working on a BRDF just for fabric materials. Fabric's ready to look great in Octane, but we will make it work even better with this system. The other major work underway is on the AOV and post-processing stack. The compositor that we just shown in 2020.2 is probably about half of the work that we want to be doing this year for you know, the AOV system itself. So we're going to be adding more tools in the imager node, and the compositor node graph will allow you to do things like leverage cryptomat. You'll be able to use OSL filters in it And more importantly, you're going to get LPEs and custom AOVs that can be generated from textures and shaders. That's been missing in Octane for a while. That should be out by the end of this year. And then along those lines, we'll also have proper AOV drivers, similar to what Arnold has per AOV. And then for post, we're also looking at adding modules that can do things like AI filters. And this is an example of one that was done in Octane. It looks beautiful. These things are actually fairly straightforward for us to add as well. As far as rendering and motion sampling, multi-region rendering, depth of field on-off toggle is going to be in there by the end of this year. And we're also working on lens effects. So improving the universal camera with things that leverage chromatic aberration, optical zoom, those are underway. And chromatic aberration, doing it in a way that's not physical is fairly easy, but we think that we have a way to do it properly and do it fast. We're also working on improvements to motion blur, and there's going to be a time node, which is useful for Orbx proxy, so you'll be able to do time shifting and time envelopes in the core. Again, with geometry, a lot of the features that we're working on involve improvement to subdivision, parametric splines and curves, and then the Boolean operators, which I showed earlier as well. And then there's other work that we're doing on coordinate mapping, smooth tangents, which will be better for parallax occlusion mapping, and UVW packing as well is underway. Spectron is going to add many more light types, parallel lights, parametric spotlights are in progress, disk and tube light primitives as well. We're going to have faster mesh lights and a proper portal light in addition to the ones we currently have. And then we're also working on proper OSL light filters. So you'll have a light manager, and we're also working on scattering of sphere primitives. We're going to call that Spectron Scatter. It'll be high performance particle shader, and you'll probably see that in the next 6 months. Scattering particles is something that we want to also be able to drive from OSL. And we're looking at having a GLSL to OSL converter for things like Touch Designer, which is used for a lot of location-based entertainment displays. And we're going to have much faster rendering for particle simulations as well. We're also looking at improving displacement with Vectron displacement. It's essentially taking the Vectron system and adding it to the surface geometry of objects. And you can have millions of instance meshes that are done this way. It's a little bit along the lines of what you could do with vertex shaders in game engines. And Vectron scattering is also going to be something that we want to move to the GPU. That's already probably about halfway done. And geoscatter as well, which is a little bit like V-ray pattern, will allow you to provide really complex geometry along the surface of any object. And then Vectron world shaders will allow us to take the Vectron system and apply that on a massive scale, not just inside of a box, which is where it's currently, but you have to do it within a certain object, but we want to be able to do it on the entire environment. So that'll go very nicely with all the world creation tools that we want to see improved with World Creators integration. We're also working on OSL trace sets and Open Color IO, which is about halfway done, should be finished at the end of this year. And then more material layer operators. As I mentioned earlier, we see this material layer system as an alternative to OSL closures. So here we want to make sure that all the possible nodes you need are there. And we've been working on improvements to things like fluorescence and phosphorescence for a while. Those have been sort of pushed a little bit further back, but we want to get to those as well as polarized lighting, sometime early next year. And polarized lighting is actually about 75% of the way done. One thing that will probably come this year is native USD support inside of both Octane and Orbx. So you'll have USD procedurals. And another highly requested feature, which we're excited to share today, is a lot of people love the C40, Octane C40 IPR node editor. And Ahmed, the developer, has agreed to work with us to bring some of these interface elements to the core of Octane. And this will mean that you can use them in other DCC tools as well. So that's pretty exciting. Sometime next year, we'll also be introducing an experimental new system, a new kernel, progressive photon mapping, which is based on it's essentially a way that you can use photon mapping to drive a caustic map. And currently, caustics in Octane can be extremely costly, as you're seeing on the right with PMC, or they can be baked with a gobo, as you're seeing on the left. So this will combine the best of those, in one technique. And you can also use it to generate irradiance caching, which is something that we want to apply for real time as well. So baking irradiance in Octane will be possible, as well as generating caustics with this kernel. And third-party formats that we're looking at supporting as well are Arnold Standard Surface, or Material X, and also Hydra. So speaking about Hydra, we have some exciting developments along those lines to share. And Hydra is part of an initiative called multi-render inside of Octane. And multi-render is meant to allow you to swap any other render engine besides Octane on the fly in a matter of seconds. It's as easy as switching between rendering kernels currently in Octane. And we're using this technique to bring our own renderers and other renderers into all of our Octane plugins. So the first ones that we want to support, of course, are Brigade, which is our real-time renderer, which we'll be showing as well talk, and an anime renderer, which is an NPR renderer that we've been developing for a while, and now is its own Hydra render delegate. And for third parties, we want to support Arnold, which is, of course, our partner on the render network, but ultimately just support any Hydra render delegate that's out there. And that work seems like it's very tractable. So we'll be showing some of those results in a little bit. First up, our anime engine, which we've been developing as a possible render kernel, we decided to break that out into its own renderer, now is running as a plugin in Octane. And you see it's running not just in Octane standalone, but it's running in Houdini Solaris as a render delegate. The anime renderer is actually pretty cool. It has line rendering and edge rendering. It's completely optimized for RTX hardware, so it runs basically in real time at 4K 30 or HD 60. And we see it having a lot of potential for cell and image rendering, which traditionally hasn't necessarily been done on the GPU. And it looks beautiful, and it runs super, super fast. And using multi-render, we don't really need to bake it into Octane. It can just run as a render delegate, a Hydra render delegate, and then you load it into Octane Core and all the Octane plugins this way. And it's simplified a lot of development. It also means we can parallelize work a lot more than we used to by having multiple render engines being developed in tandem and then sort of bridging those together. So next, I want to show how Arnold works with the multi-render system, and this is really cool. So this is Octane standalone, rendering Arnold live, and this is me switching between Octane and Arnold. This is Octane. 1 second, it's now Arnold. That's pretty amazing. So that's how fast it takes to switch between two different renderers. I'll show you. Here's another example from the Octane 1 splash screen documentation. This is an Octane. I'm switching to Arnold, and in about a split second, it's rendering in Arnold. That's pretty great. And you can use the Arnold film buffer with all of the Octane post-processing effects, and you can even control the Arnold viewport directly, as you would the Octane one. So it's basically like a render kernel, but it's using a completely third-party rendering path. And with that, you can also do many other effects that have been tricky to do in the past. For example, you can render both Arnold and Octane at the very same time. This is all within Octane standalone, and combine those viewports and mix those with post effects. So that compositor tool that I had shown before, well, you can now take that and let me go back a slide here, and you can use that to take certain elements from Arnold or Octane or even another renderer and composite those together. So the volumes from one renderer and the scenes from another can actually be composited live at render time. And we support both Arnold CPU and GPU in this framework, and you can see material conversions already pretty far along, and more is to come. So we've also, along the with Arnold, supported Pixar's Storm Render, which is a preview renderer, and Intel Embry, which you can see on the left. And those just basically come with the Hydra SDK. But there's a lot more out there. So we're also, of course, going to be bringing the system to all of these plugins. So if you want to use Arnold inside of Unreal, it's going to be possible to do that. Every single one of our GTC plugins will now become a system capable of supporting Hydra render delegates. And in the world of rendering, there's a lot of renderers that are being adapted. So one of the ones that's already nearly working is Cycles. So you'll be able to just use Cycles inside of any of our existing plugins. Of course, Arnold. The Omniverse renderer, which looks fantastic, is built on Hydra, and we're talking to NVIDIA about bringing that into render. And there's many more out there, many more open source ones that we could probably just build and ship for free with Octane, and that includes Google Filament, LuxRender, Intel Osprey. They're all open source like cycles, and they all can be, when they're further enough along, shipped as free renders that go alongside Octane and Brigade. So the two cases that are really interesting and kind of doable with this system are Unreal and Blender. Now we have the full source code to both of these tools. UDK and Blender both are buildable by us. In fact, we ship a custom version of Blender just to support Octane. And we can compile these into special modules that expose their built-in renders as render delegates. So that means Eevee and even Unreal Engine could be added to multi-render. And you could just switch to Unreal Engine or Eevee with the system. And that's pretty mind-blowing. But all of this work we've done for a specific purpose, which is we wanted to get our own real-time renderer Brigade into all of the Octane plugins, and everything else, frankly, is nice. But Brigade is really the core focus of why multi-render exists, because Brigade is the future of where we see GPU rendering going. Octane will always have a place. The quality of spectral rendering is absolutely fantastic, but we've always wanted to see real-time have come to fruition. And with RTX hardware now, and the majority of our users now have a Turing or later card, and especially with Ampere, we're seeing real-time becoming much more viable. When we first started talking about Brigade and showing demos, it was running on the equivalent of 80 K80. This is about 3,200 Octane bench is what this was showing, and that's what it would take to get Brigade running in real-time 720p 30 as the example here. But it really was just a question of scaling. And with RTX hardware, the scenes that are leveraging Brigade, Brigade's written from the ground up to leverage RTX. It's written in Render. It's not using CUDA or optics. And in Vulkan, we're seeing pretty great performance. Info channels, for example, which we got working in 2019, or even direct lighting, it's super simple to get that running at 4K in 60 or 30 frames a second. And that's what RTX hardware delivers. And so Brigade, if you're just trying to replicate what Octane's doing in direct lighting or info channels, right out of the box, you get noise-free results, and it just works great. But direct lighting and info passes and AO are not path tracing. And obviously Octane, when you're creating final renders, it's using path tracing. So this year, we started to show the first results of Brigade's path tracing kernel. And to be frank, I think it's pretty awesome. This is Octane on the left, Brigade on the right, 4 samples per pixel. Brigade is just able to render it faster and get there quicker. Now, there is always going to be a difference. I mean, Brigade quality is really, really, really good. I mean, it is full path tracing, no shortcuts, but it's not spectral. It's an RGB renderer. The material system is not as advanced as Octane's. But nevertheless, you have scenes like this one, ArchViz scenes, Octane on the left, and you have Brigade on the right, and they don't look that different, except the one on the right is rendering at 60 frames a second with path tracing. It's pretty incredible. So designing Brigade from scratch around RTX, I think, has been a good bet. And while we weren't sure that path tracing would actually work at this speed, we're now reasonably certain that we're going to make that happen and get that into users' hands. So we've also gotten really good volume rendering support inside of Brigade. You have instant environment volumes, so you have God rays for free, basically. The medium node in the Octane environment is replicated in Brigade, but it is essentially real time and very fast and very little noise. So if you take Sculptron lights, for example, like we're showing here, those inside of Brigade are awesome. I mean, you actually can get caustics out of Sculptron lights, which is pretty amazing. Refractions, which we didn't show 6 months ago, we're working really well on Brigade. This is showing IOR refractions in real time. Looks beautiful. Again, basically free and in real time. And we also have been able to master really complex things like path traced volume caustics, which you're seeing here. That basically doesn't even render anywhere near real time in Octane. And here we have that running in Brigade. It only works with Sculptron lights, but still super useful. And we've also been working on very fast depth of field effects. That's still sort of a work in progress, but it's running really nicely, even on a 2080, which you're seeing here. Now, there's other types of caustics as well, refractive caustics, which are really tricky. You saw that working there. It's just an early work in progress. Subsurface scattering is also in progress. Chromatic lens effects, we actually have those already running in Brigade. They're running pretty much in real time. And what I'm going to show next is probably the hardest and worst case scenario in Brigade, which is mesh lights, mini mesh lights in an interior scene. This is running not always at 60. I mean, it drops down to about 10 frames a second. And there is a little bit of noise and splotchiness, but it's working. And it's still pretty early. But this shows that, yeah, you'll be able to render pretty much anything with Brigade, and it'll still be real time. So next, I want to show what real production scenes look like in Brigade, because that obviously is better than just demos. And some of these I posted on Twitter and social media, but this is more of a deep dive in them. So we're going to take scenes that we've rendered for a while in Octane, and they're exemplary, and show them in Brigade and see what the difference is. So this is one example of a scene, and you can see on the left, Octane rendering, which is actually pretty fast, and Brigade on the right, but Brigade is rendering it at 60 frames a second. There's probably greater scattering depth in the Octane one on the left, but this is a scene where the spectral rendering, yeah, you don't really miss it so much. I will say that having used both of these renderers now, it's a little bit harder to get the quality that I want right out of the box in Brigade, but I think with time you can really get that to work, and that's something that, again, is probably limited by the fact that Brigade is still pretty early, but it looks awesome. The daylight system from Octane is fully replicated in Brigade. Again, it's real time. Things like turbidity and, again, volume caustics, really trivial to do. Next scene is a famous scene that's done by Rick the Asian from the Octane 3 splash screen. This was something that actually did render faster with RTX, even in Octane, but nowhere near real time. So on the left here, I'm showing the Octane version. On the right, Brigade, on the same GPU, and the difference is absolutely stunning. Again, in this particular scene, the quality is pretty close in terms of, if you actually look at the final renders, they're pretty similar, but Brigade is just going through this thing so much faster. And the reason for that is that, again, it's a simpler renderer, so the material system is a bit simpler, and this scene doesn't necessarily push that. If you were to do layered materials, for example, that wouldn't work in Brigade. And there are many things that are, that are still missing. Like, we don't have volumes, we don't have hair, we don't have motion blur just yet. But for things that do fit within the features that are currently in Brigade, the results are just incredible. Here is another example showing the daylight system close up. And you also have caustics and other things as well that are in this environment, and it's amazing. I mean, it is a world of difference to be able to take a scene that is close to production ready right out of the box and keep editing it and using it at 60 frames a second. And so Brigade is truly, again, seeing the progress we've made in the last 6 months feels awesome. Now, a lot of questions we get is, when is this coming out? The answer to that is sometime next year. We may have a demo or a benchmark or something the end of this year, because clearly it's fun to play with even in the current state. But we do want to get it to a point where it's built into multi-render and it just works with most scenes out of the box before we, make it something that artists get to really play with. Here's another scene. I think this one's even bigger than the last one. This was the Octane 2 demo scene that uses tons of instancing. And the scene is actually using a truck from Evermotion. Again, Octane on the left, Brigade on the right. Pretty close in quality. I would say almost the same in a lot of respects. And you have the Brigade one on the right here. The one on the left in Octane, which is basically on the same GPU, actually struggles to capture video. It's just pretty noisy. The difference between the two is just pretty crazy. And here's the Brigade one again, 60 frames a second, full path tracing, just works. Actually, let me back. This example is me testing it on a 4K display. This is on a Quadra A6000. 3090 is about the same speed, but this is 4K. 4K rendering this scene. It's on one GPU, and that was rendering, by the way, at 60 frames a second. If you go back to the slide here, you can see it's rendering this frame at 19 milliseconds. Absolutely stunning. So how does Embergen and Brigade work together? We've already done some tests with that. We actually want to support VDB volumes. So you can see here there's volume rendering working inside of Brigade. It slows the frame rate down to about 30 frames a second on a 2080, but it's 60 on a 3090. And you can also see here, this is just one snapshot of the Embergen simulation, but it works. The volumes cast shadows, and scattering, single scattering at least works in volumes, so it's pretty cool. And being able to get volumes this early into the Brigade engine is great. And of course, with Embergen simulating stuff in real time while you're rendering in real time, amazing things are possible here. I showed this previously. Brigade has a light caching system. It can take essentially the output of irradiance, which we're developing for the PPM kernel in Octane, and it can use that to skip the GI step inside the rendering. Now, that's kind of useful for games, but as you've seen with these other videos, Brigade's fast enough to do full path tracing without any sort of tricks. But this is something that we think is actually pretty useful for non-RTX cards, and in particular, iOS devices with ARKit. We are building Octane and Brigade for iOS, so in this case, having the irradiance cache is going to be super useful. As far as render modules go, there's more than just render plugins, right? We have Embergen, we have World Creator. The module system itself is divided into sort of three parts. You have physics tools, and you also have procedural tools as well. But for physics, we're adding our own soft body and rigid body physics system. It's based on PhysX and Bullet. You can have two backends, so it'll allow you to drop in different physics engines. This is actually an early Brigade test running Bullet while I was doing path tracing. So we just want that to be built into the render stack. And I think it's fairly similar to the work being done by Omniverse with NVIDIA dropping PhysX inside of their system. So we see all these efforts as complementary. This is a product called Storm running with Octane, and it's used for grain simulation. It looks awesome. And we're working with the developer to port Storm to CUDA and to get it to work on the GPU. And we're probably at that point going to look at offering it as another render module along with the rest. Sculptron, our GPU sculpting tool, it's really powerful, and it's been available since last year, but we've made another release this year that has a lot of new features. There's a timeline, a whole new UI workflow as well, and that was this alpha was released in July. It is a lot faster than the previous version by a factor of 10. And again, entire system is based on the GPU. So you have a GPU sculpting tool. All the tools that we want to introduce alongside Octane are typically taking problems that were CPU workflow problems and getting them adapted to the GPU for huge increases in speed. So for the future, we want to have full USD support in Sculptron. We're building a mesh modifier stack that allow you to do all sorts of operations in a node-based system. And we're also going to be adapting Sculptron for the iPad and for tablets. And we want to support authoring forces, fields, and physics-based operations. The list of things we're adding to Sculptron over the next year or two is pretty huge. But it'll be a really nice, simple DCC tool at the end of the day with a focus, of course, on sculpting and temporal sculpting in particular. Next, I want to talk about OctaneX, which was a release that we put out this year on Metal. After 10 years, we ported Octane from CUDA to Metal. And one of the things that's amazing with this work is that we actually have all of Octane completely running on the iPhone. This is my iPhone 11 running PMC kernel, and you can just take any Octane scene and it just renders without any difference to the CUDA version on an iPhone device. And it's pretty fast. I mean, it's 15 Octane bench. It's about the same speed as an Intel MacBook GPU, 2020 13-inch MacBook Pro, right? That's crazy. So if you actually were to take your iPhone and add it with network rendering to your MacBook, you'd have double the speed. But it's really fast for interactive rendering. And why this matters is that we want to get everything running on the iPhone because we want to have this for AR and other things. But you could do full production rendering on your phone. You can actually, in this case here, we're starting a scene, and the final renders just look absolutely beautiful. It's pretty incredible. So you can kick off, of course, renders that are started on a phone to render. That's kind of the point. So probably OctaneX on iPhones will remain free, and we'll subsidize that through render jobs. And as I was saying before, you can actually use network rendering with the iPhone to double the speed if you're rendering on a MacBook, or even provide GPU rendering at 15 Octane bench to a device that doesn't have any of that. Now, with Brigade and OctaneX on the iPhone and having the full stack there, we see a lot of potential in AR. So going back to what we were showing before with the irradiance cache, here's Another example, I've seen from Keloid, that's running on an iPad. The radiance is cached, but it's running pretty much in real time in AR on that phone, and it's only doing reflections. GI is essentially baked in. We don't have to bake it in. We can, we can calculate it in real time, and it's pretty fast. But again, we're not talking about thousands of Octane bench here. We're talking 15 Octane bench. So we want to come up with ways that address AR in real time in clever ways. Here's just one character from that scene. Some of the tools that we're developing for Octane on iOS include really good tracking. That's improved a lot with the LiDAR tracking, but we can also do marker-based tracking. And an important consideration here for making AR truly work is being able to do lighting. Being able to sample the scene is something ARKit kind of does for you, but we built a custom solution, and that allows us to do really complex things like you're seeing here, where we can do live ray trace reflections on objects and scenes, and that looks pretty great. So if we can feed that into the ray tracer, you can really do on-set compositing and rendering with this system. Now, some of these assets that are coming in from Octane can have pre-computed radiance, but a lot of cases, things are dynamic. So, we don't have that, or we have to do it in a little more, clever way. So I want to show dynamic scenes next. And here's an example from Keloid. That very same robot is actually dynamic in this example here. This is something that was maybe a year old. The newer version is actually really nice. So this is a more recent version of the renderer, and it's pretty close to the production version that we have on the desktop, while still staying in real time. And we subsequently added support for things like motion blur inside of AR, which is great. So the idea with this is that you've had viral videos that are done with, let's say, Octane for C4D, like the example on the right, taking an asset and spitting that out on Instagram, and it's really popular. Also, something that we think a lot of consumers using an iPhone would really enjoy. So being able to take all of that and do it all from a phone, like we're showing on the left, is, I think, a game changer. And we want to see more of these kinds of effects done with Octane for iPhone, but it also allows you to do really cool AR effects. But I think just from the perspective of what you can do offline, like these videos are insanely cool, and they're all done in Octane, but they're done on the desktop. So when you're talking about production scenes going into a system like this, like here's an example of an Orbex file done by BLR, and on the right is that same dynamic scene with destruction and everything running on the iPhone in Brigade mode with hybrid rendering, and it looks pretty good. It looks pretty good. So again, dynamic scenes with Octane or Brigade rendering them live is viable. I mean, I think the best for real time is basically Brigade with the irradiance cache, or no irradiance at all, like we're seeing here, and you still get great effects. So the future, of course, is with AR is probably not just limited to phones. We think glasses are going to be a thing as both Facebook and possibly Apple and others develop lightweight glasses. But there is something better than those in our view, or at least complementary, and that's holographic display panels. And a big goal of Otoy's is to help build a software in the pipeline that powers the holodeck. And we were fortunate enough to partner with a company that's actually building true holographic display panels. That's Lightfield Lab. We have a multi-year partnership with them, and they're building these massive and complex holographic display panels that can be used for location-based entertainment or tabletop panels that allow you to see 3D and volumetric effects without any glasses whatsoever. And it's very difficult to describe how cool these things are without seeing it live. And even developing for it's been tricky. So to develop on the display, we built a simulator. It just projects, using head tracking, what you'd see on the display live. And to power these displays, the real ones, it's about 32K by 32K per square foot. We need about 15 RTX 6000s to drive it. Maybe now we'd need a lot less with the A6000 cards, probably about a quarter of that. But this is the future. I mean, there's no doubt in our minds that in 5 or 6 years, you're going to see a lot of high-end displays be holographic, which are going to have insane pixel resolutions. And ray tracing and RTX and all these things we're working on are a big part of making that work. This is an example that I can speak to. I've seen that very same scene on the display and on the simulator, and that one in the real holographic display panel, it's incredible. I mean, you just have convergence. You have things that you just don't see even with shutter glasses or VR that are visible on a true light field display. And the way that the light field displays work is they're tileable, so you can just keep adding more of them. It's like the Samsung video wall. And it's just limited only by cost. So if you want a true holodeck in your home, you can do that. It just costs a lot. But those things will go down in price, like any display technology. The first 100-inch sets may cost $100,000. 4K plasma displays were that as well when they first came out. And now they're $300. So, you know, there's a huge cost savings that comes from scale. So as these become more, you know, they sort of scale in volume in terms of their market share, that's going to be something that brings the price down. And that's why we think this will become a commodity in the coming decade. So looking at the 2030s, again, maybe 10 years from now, I'll be doing my 20th GTC talk. Holographic display panels, absolutely a thing. That's going to be driving massive demand for rendering power, both from the cloud and even on-premise. Again, a gigapixel panel powered even by a single GPU is pretty tough. I mean, we're maybe at 10 or 15 frames a second with multiple GPUs. We need to get to 60. On the other side of the spectrum, I see the mobile devices that are in your hand getting to about 300 Octane bench from the 15 we are now. I mean, just looking at 30% year to year times 10 or 11 years gets you close to that. And our work with the iPhone has actually been really promising. I mean, it's actually getting about 6 Octane bench per watt, which is 3 times faster or more than what the desktop GPUs are doing. But with NVIDIA buying ARM, I mean, there's no doubt that you're going to see probably single SoCs like what you see on the iPhone that have really powerful GPUs, ray tracing hardware, tensor cores, all in a small form factor, and that could power future glasses, or phones, or even holographic display panels. Right? Those things need to shrink a lot. So that will happen, I think, in 10 years, and you're going to see probably about 100 Octane bench per watt or more. In that time frame, and we're in the 1 to 2 to 6, right? So that's some huge improvement that I think will happen in the next decade. And the other trend, just looking ahead really far out, is that a huge part of content creation, right, which right now is just computation bound, right? We're doing ray tracing, doing all these things. AI will solve a lot of that. We obviously have things today like the AI denoiser and other things that improve the workflow, but it's possible that things like neural rendering might actually be just as good as ray trace rendering. And who knows? That's something that we'll sort of be looking at closely, as many others, in the coming years. But in 10 years' time, I think there's a good chance that you'll be able to have really excellent AI rendering and probably really great AI capture as well, which will make things like AR and mixed reality pretty compelling. So to close out, I think the future is really bright. I mean, we had an amazing decade in terms of GPU power, and just seeing the industry shift to GPU for both offline rendering and, of course, RTX now for games is has become mainstream. I think the next 10 years is going to be amazing as well. And our goal as a company, I think, is similar to Epic's and others. I mean, we want to see an open metaverse. We think that the web itself is a great model for how software and services should interact. And our goals with Render have been to develop interoperability and a way for many different vendors and partners to leverage a unified system, open standards, and decentralization where possible. And that future is great. So thank you very much. It's been another great GTC, and I'll see you all next year. This is Jules Urbach signing off. Thank you very much.